Hello students, welcome to IMS GATE Academy. In the last session, I started analog circuits. There I started the topic of diode circuits. I have done certain number of the problems also. Today also I am going to do certain number of the problems from the diode circuits. Try to understand and practice these questions. Yes, I will start now. I think the foundation course will be helping each and every students to a lot. Every student will get benefit because of gaining the basics, I can say that now. Yes, we can start the now. But I wish to give the question from the diode circuits. Please try to do this question. For the circuit shown, for the circuit shown, in the figure, assume ideal, ideal what? Ideal diodes, with zero forward, zero forward resistance, and zero forward voltage drop, zero forward voltage drop. Voltage drop. The current through the diode D2, the current through the D2 in milliamperes, is dash. Here the network is given like this. A resistance of 200 ohms here connected, 200 ohms. There is a battery, that voltage is given 10 volts, and this side one diode is connected. This is a D1 it is given, and here connected with 10 volts. This battery is connected with 10 volts. These two are connected like this. Diode D2 is connected this side. There is a diode D2, but this is connected with 8 volts. This is connected with 8 volts. This is the given problem. I'll check the values: 10 volts, D1, 200 ohms, 10 volts, D2 and 8 volts. Yes, this is the given problem. How we can complete this question is more important. What is asking in the problem? For the circuit shown in the figure, assume ideal diodes. Diodes are ideal is given. Diodes are ideal means what is the meaning? The drop across each diode is 0 voltage. There is no drop across each diode. That is why it is given 0 forward resistance and 0 forward voltage drop. The current through the diode D2 I want. This current I want. I want current this side. I want this current only. Current to the diode D2 also. But because of the connected supplies, because of the connection of the batteries, Can you say which diode will be on and which diode will be off? D1 is there here. Do you have any resistance? No resistance here. Now, this will be on or off. 10 here, the 10 minus 10, 0. 0 current will flow. This side, no chance to flow the current only now. This minus this is taken means 0 voltage only. 10 minus 10, anode voltage 10, cathode voltage what now? This voltage is what now? 10 minus 10 by this means impossible now. Anyhow, this diode will be off state only possible. This will not operate. Two potentials are same this side. D2 and D1, D2 is on, D1 is off. Very good, Satya. Satyavardhan, exactly correct. D2 is on, 100% perfect. This side 10 voltage you got now, anode side, cathode side 8 voltage we got. This is on state, 100% perfect. Now in this case, this can act as a open circuit only here now. This is open circuit. Only this network only possible. Current will pass in this direction. So current through the diode D2, I want to take it as a ID2. ID2 I want to denote. This is open circuit, not working. 10 minus Ohm's law you can apply. 10 minus 8 by resistance is a 200. So 2 by 200 is possible here now. If you are using the calculator, ID2 will be 10 milliamperes possible here now. 10 milliamperes of current is passing. So current to the diode D2 is 10 milliamperes. No current will pass across this D1. That is the solution. Yes, I want to give one more question in your hand. The next question. Now you please try this question. The slight change I will give. The diode D used in the circuit below. You make an effort to get answer. Is ideal. Is given. The voltage drop VAB, V suffix AB is given. VAB across 1 kilo ohm resistor in volts is dash. I will give the network. You please try this question. Here connected with 3 volts. This voltage is given with 3 volts. And here connected with 1 kilo ohm resistor. There is 1 kilo ohm resistor. And there is a diode. D. And here connected with 5 kilo ohm resistor. This side 5 kilo ohm resistance is given. And this side 1 milliampere current is connected here now. This current is given 1 milliampere. This point is given A. This point is given B. But is asking to find voltage across this AB. VAB I want. It is nothing but voltage across 1 kilo ohm. Anybody can do this question without my help? But I want to wait for some time. Anybody can give answer? If you got answer, very good. VAB is required. When I can get VAB, voltage across 1 kilo ohm, if diode is on. If diode is on, it is the ideal diode is given, it can act as a short circuit and current will pass. When current is passing, some drop is available. If you don't find any current, you will not get any voltage drop. We can check. How we can find the current across this 1 kilo ohm? Nodal analysis I can apply. This node voltage I want to take it as a V. By using nodal, any method you can apply as you like. According to nodal, this current plus, this current plus, this current equal to 0. By using nodal analysis, I wish to find initially voltage V. Once I got the voltage V, I can measure the current. 3 minus V by 1K to get the current. If you got the current, you can measure the voltage also, voltage across this. How you can apply the nodal analysis here? As per nodal, this direction V minus 3 by 1K, V minus 3 by 1 kilo ohm. 1 kilo ohm means 1000 I can put. Plus, we don't have any voltage drop across this diode because it is given ideal. Drop across diode is 0 only. What about this current V by 5K, V by 5000, V by 5000 I can put. This side current is nothing but 1 milliampere, but direction taken reverse. Reverse means minus 1 milli, 1 into 10 power minus 3. Summation of all the currents equal to 0 at that node. Here, I would like to take the what now 5000 LCM here now for these two. 5000. How many times you can cancel here now? 5 times. 1000 means 5 times 5V, 5 3 is 15, plus V equal to 10 power minus 3, I can get here now. When you cross multiplied 5 into 10 power 3, this will be cancelled out. 5 plus 1, 6V minus 15 equal to how much? I will get here now 5 only now. This side I can get now. V equal to how much it is possible? 20 by 6 it is possible. 20 by 6 equal to how much? Anybody? 20 by 6, 3.33 volts it comes. 3.33 volts here possible. Now check this point. This side we got this V equal to 3.33 volts. 33 volts possible now. Can you find any current to the diode here now? Now diode is a forward bias or reverse bias? Yes, Satyavardhan says answer is 0. 100% perfect. You are correct. Because whenever this anode voltage we are getting the 3 voltage, cathode voltage is nothing but 3.33. If the anode voltage is greater than what now? Cathode voltage, then only current will flow. In this case, current across diode is 0 only now. Anode voltage is less than we are getting here now. Anode voltage is less than I am getting here now. Less than cathode voltage I got. This is the cathode voltage. So diode is off. If diode is off, current passing through the diode equal to what? 0. When current through the diode is 0 means voltage across 1 kilo ohm will be 0 voltage only possible. Why sir? Current is 0. Current into resistance, 0 voltage only possible. Finally, answer is 0 volts we can put now. That is the answer. Yes, I wish to give one more good question in your hand. You please try this one. One more problem I will give. The silicon diode, the silicon diode shown in the figure, shown in the figure has a barrier potential, barrier potential of 0.7 volts. There will be no forward current. There will be no forward current. No forward current is given. No forward current. flows through flows through the diode, flows through the diode. If VDC, DC voltage, if VDC in volts is greater than that's all given, greater than, that's all. Here the network is given like this. There is a diode here. You please try this question. There is a diode here connected with one resistor. Its value is nothing but 500 ohms. This supply voltage is given 2 volts. Here connected with one of the battery. This is connected to the ground. This voltage is given VDC by 2. Yes, this is the given problem. Anybody can find this value? What is asking in the problem? The silicon diode shown in the figure has a barrier potential of 0.7 voltage. Voltage across the diode is given. How much voltage is given? 0.7 voltage. There will be no forward current flows through the diode. That means current passing through this diode is a 0, it says, through the diode. If VDC in volts is greater than, that means if the VDC is greater than what value, we need to maintain to make current through the diode 0 only. Current through the diode must be 0. Means VDC is here greater than what value required. Greater than what value, if you maintain, you can make the current through the diode 0. Anybody can do this question without my help? Anybody? How we can find this answer? I would like to wait for some time. Please try this. Are you trying, Satyavardhan? Are you trying this question? May I know that? Are you trying or not trying? Okay, I will do. Please watch. I wish to give the solution. The current passing through the diode must be 0 required. In that case, VDC must be greater than what value? What I can do here now, first of all, first this circuit I have taken, what is the current equation from this network I will take at first. And finally, I will put I equal to 0 there now. I would like to form an equation. By using the KVL, I will form the equation now. In terms of I, you will get I and VDC. When I equal to 0, VDC you will get something. So to make I equal to 0, VDC must be greater than the value what we are getting over now. I say when KVL is applied, so current directly we can take in other words now. I equal to, we can write directly. By using the Ohm's law, we can get answer directly. I equal to what? 2 minus this voltage minus this voltage, VDC by 2, minus some drop is possible across the diode is given. There is a 0.7 I can write. Must be divided by total resistance. What is the total resistance? 500 ohms it is given. 500 ohms it is given. But I want to make the current to the what? No, diode 0 only now. Current to the diode is to be made, forward current is to be made 0 means what VDC required? put I equal to 0 here. When I is 0, 0 equal to what I will get? 2 minus 0.7 minus VDC by 2 I can get here now. This into 0, 0 only possible. Then finally VDC by 2, VDC equal to how much I can get? 1.3 into 2 is possible. 1.3 into 2 is nothing but 2.6 voltage is available. 2.6 voltage possible. If you are maintaining VDC value greater than 2.6 voltage, you think it's so. Greater than 2.6, whatever the voltage you maintain, 100% diode will be in the reverse bias only now. If it is a reverse bias means it won't pass any current only now. So I equal to 0 means VDC, that much I got now. Even you maintain VDC greater than what now? 0, greater than 2.6 voltage, current becomes 0. So what we can write now? VDC must be greater than 2.6 voltage you have to maintain to make current through this diode 0 value. That is the answer for this question. And I wish to give one more question in your hand. You please try now. With a slight change, I will give one more. The next problem. In the circuit shown, for the diode circuit, for the diode circuit, shown V cut-in voltage of diode is given 0.7 voltage. Cut-in voltage across the diode is given here. Find ID is asking to measure current through the diode. Find ID. Here network is given like this. Resistors are connected this side. One is 7K, one more is nothing but 3K here connected. The supply voltage is given 10 volts here. 10 volts here given. There is a diode here. There is a diode. And here connected with 2 more resistors like this. One of the resistance is given 7K and another one is given 3K. And the voltage here connected is 10 volts. Is asking to measure current passing through this diode. ID is asking to measure. Yes, that value is required. Can you get answer for this question? What current is passing through the diode from the given network? Anybody can try? Anybody can do? The initial work is yours. You put an effort to get answer. It's a 10 volts both, 7K, 3K, 3K, 7K given. Current through this required. But in this problem, what you have to do, you form this as a single equation. Single equation you can form here now. Single equation I want. Single loop equation I want to form. Single loop equation whenever you are getting, otherwise one series circuit I want to form here now. Once we form one series circuit, easily you can determine the required value. What way we can do here? What way means please was. By using the Thevenin's theorem, equivalent circuit you find this side. By using Thevenin's, this equivalent circuit you find it. Thevenin's equivalent circuit this side, Thevenin's this side you form. Unconnected diode only now. But Thevenin's, what happened now, initially you must take this as a open circuit. This is open circuit. This is totally open circuit. I considered only this circuit. But in this case, VTH1, Thevenin's voltage 1 I will get, because two circuits are there, this side and that side. Thevenin's voltage 1 I want to get. Thevenin's voltage means voltage across this, how much you need to find. VTH1, we need to calculate. Voltage across 7K. The supply voltage 10 volts given means same current is passing this side. VTH is nothing but voltage across 7K. According to voltage divider formula, 10 into 7 by 7K by 7 plus 3, 10K. 10, 10 cancelled, we are getting the 7 volts. I got 7 volts. Then after you need to make a view this side. You need to make a view this side. When the view is made this side, DC supply is to be shorted. When the view is made, 7K and 3K are in parallel. When the view is made, one resistance this side, one resistance opposite side, parallel both. So RTH1 I can find. Thevenin's resistance 1 I can get now. 3 into 7, R1, R2 by R1 plus R2. 7 plus 3, 10. 21 by 10 becomes 2.1 ohms possible. That is VTH and RTH. In the same way, this also I want to simplify. This is open circuit. This side it is a open. By using this network, I want to find what is VTH2. VTH2 is nothing but voltage across 3K. I can determine VTH2 again. Voltage across 3K is nothing but 10 into 3 by 7 plus 3, 10. I'll get 3 voltage. And the resistance will be same. RTH2 is nothing but, when the view is made from this side, these and these are in parallel. 7 into 3, 21 by, what is possible? So 2.1 K is possible, kilo only possible. 3K, this is a kilo ohms only possible. This is possible in kilo ohms. 21 by 10 is nothing but 2.1 kilo ohms it is possible. Once you simplify it such a way, you can redraw this network. This side we are getting one Thevenin's voltage, VTH1. VTH1 is nothing but how much? 7 volts. According to Thevenin's, voltage in series to the resistor is must, Thevenin's resistance. That is 2.1 K you will get here now. And here the diode is to be connected. Same diode is to be connected this side. And these are here also Thevenin's equivalent circuit required. Thevenin's means one resistance with a battery is must. The resistance is same, 2.1 K kilo ohms only now, 2.1 kilo ohms. This voltage is nothing but 3 volts. But I am in need of this current ID. Diode current I want. Now it is very simple. Current through the diode is nothing but, diode is given ideal or non-ideal? Non-ideal. Cut-in voltage 0.7 given. ID equal to 7 minus 3 minus 0.7 by total resistance. We can use. According to Ohm's law, we can find ID equal to what? 7 minus that side voltage 3 divide minus of, still we got voltage across the diode also, here we got voltage across diode is nothing but 0.7, 0.7 I can write, divide by how much? 2.1 K, 2.1 K, 4.2 K possible. And use calculator, you will get the diode current here. The diode current is, the diode current you will get, this value will be, this 0.785, 785 milliamperes of current is passing. Such a way, the value of ID is calculated. The same model question, one more problem I want to give in your hand. Once you completed that problem, I will change again the model of the problem. Understand now? Yes, I will give one more question. You please try this now again. Yes, now the problem is given like this. the current I, the current I, the current I is required here now. In the circuit shown below, in the circuit shown below, in the circuit shown below, in the circuit shown below is, in the bracket it is given, assume that diode is ideal. Assume that diode is ideal is given in a problem directly given. And here given network like this. There is voltage source of 20 volts, 4 kilo ohm resistance, here it is existing, 4K, 4 kilo ohm, and one more 4 kilo ohm here connected. One more 4 kilo ohm here connected. And there is a diode here. There is a diode. Here the 2 kilo ohm resistance is connected here. 2K is connected here. And here one battery also connected, that is 6 volts. Is asking to measure this current. Current through this diode is asking to find. Please get answer for this question. Anybody can give answer for this question? Anybody can give? What answer is possible? But I want current passing through the diode. This I can get in this way. You please watch, I will do. You will get an idea. You can also try if possible. Just like a last problem, we can complete this question. Initially, this circuit is an open circuit. This is open. You find what is VTH and RTH from this network. You connect and directly you will get ID1. I say VTH is nothing but voltage across this 4 kilo ohm is nothing but VTH. Voltage across 4 kilo ohm means 20 into, according to voltage divider formula, 20 into 4 by 4 plus 4, 8. And you will get the what now VTH directly. What VTH is possible? Otherwise, directly you can measure the current, I think, by using the nodal. Still, why? If suppose one more way we can do, otherwise, one more way I will do. This is one of the method by finding the what now? Thevenins. So, one more method I will explain best. Directly by using the what now? Nodal analysis, you can get answer. Still easy. These lines also not required. These are all unnecessary. Directly you can get now. Still easy way I am giving. But this is one of the method. If not required, you can use this also, this method also. This voltage I selected V, nodal voltage V. Once we got this node voltage V, you can measure the current, this current. According to nodal, this current plus, this current plus, this current equal to 0 only. Diode is given ideal. When diode is ideal, it doesn't flow any current, sorry, it doesn't have any drop. Drop across diode is 0 only now. As per nodal, V minus 20 by how much? 4K. All are in kilo ohms only, 4 plus V by 4K, V by 4 plus V minus 6 by 2, that equal to 0. That equal to 0. No drop across the diode. I can cancel 2 times, 2 2's and 2 2's I can cancel. What is LCM? 2 is LCM. So, V minus 20 plus V plus 2V minus 12, that equal to 0. 2 plus 3, 4, 4V I can get this side. This side 20, 32 voltage it is possible. V equal to how much possible? 32 by 4. But we are going to get 8 voltage. V equal to 8 voltage we are getting. Once we got this voltage V, you can measure ID by using the Ohm's law. I say current passing through the diode, I can determine V minus 6 by 2K only. The V is nothing but the 8 minus that side voltage 6 by, what about the resistance? 2K we got. So I will get 8 minus 6, 2 by 2K I can get now. This is equal to 1 milliampere of current is possible. Yes, this is the answer for this question. I think you followed this method. I don't want this nodal star. Yes, you try. VTH you find, RTH you find, connect in series, directly apply the what now? Ohm's law. You will get answer that way also. And I wish to give one more question. You please try this question. The one more problem I want to give in your hand. If you completed this question, I will change the model next. One more rule I will give and I will do question based upon that. First this problem you complete, then after one more method I will explain after this question. The ID2 current, current through the diode D2, ID2 current in milliamperes. If parallel diode configuration is parallel diode configuration is given, is given as the network given here like this, 10 volts here connected. You please make an effort to give your answer. You give your answer at first. 0.33 here resistor here, 0.33 kilo ohm resistor is given. There is a diode this side. It is made up of silicon. Diode D1, I wish to take this now. And one more diode is connected this side. Parallel to this, one more diode is connected. It is also made up of same silicon. It's a diode D2 only here now. Yes, that is the given problem. But this current is given ID1. This current is given ID2. This is ID2. But is asking to measure ID2. What ID2 current passes is required? Please try this question. You please try this question without my help. Both are silicon, no doubt. Both are silicon means they are not connected by any resistors. 100%. Both will be on only possible here. Both will be on. And also two diodes are what now made up of silicon means current across D1 and current across D2 will be same. This net current passing through the what now 0.33 K is nothing but I you put it. Once you got I, ID2 equal to I by 2. I by 2, half of the current this side, rest of current this side will flow. Yes, you complete this question without my help. How you can do this question? We can do like this. This current I want to denote by symbol I. We know very well this node voltage is well known to you. This voltage is well known. What is this current? This voltage across this diode. There is a 0.7 voltage here possible. Voltage across each diode is a 0.7 only now. But this current I can measure 10 minus 0.7 by 0.33 K. I will get the I. ID2 is nothing but I by 2. Half of the current will flow. I say I is nothing but 10 minus 0.7 divide by 0.33 K. 0.33 K. I will get 9.3 divided by 0.33 K possible. Finally, this value will be, that current is 28.18 milliamperes of current is passing. 28.18 milliamperes of current is passing. But ID2 equal to what I said, half of this current will flow this side. Both are same, both diodes. But equal values possible here now. ID2 equal to, otherwise ID1 equal to, both are same, that equal to I by 2. I can write 28.18 by 2 possible. And you are going to get here now 14.09 milliamperes possible. 0.9 milliamperes of current is passing. Yes, that much current is passing through this diode D2, we can say. And with a slight change, I want to give one more question. If I want to do the next question, a small rule I need to explain. After explaining the rules, I can do the problem only now. Understand? What is that rule? Now listen. The next model, what I wish to say, suppose so far you have seen every problem with what? DC supply. Only DC supply I connected. If I connected AC and DC, if I connected to the diode AC and DC, both are connected, what way we can do? First I will give the method, then after I will do the question only now. Suppose you are given here, that means what happen now? Diode with AC and DC supply. AC and DC supply, suppose given. In that case, how you can do? Sometimes asking in the competitive exams or engineering service or gates. Suppose I connected here one DC supply like this. There is a V. I connected one of the AC supply here now, small v. V equal to Vm sin omega t or something, or cos omega t. Anyone I will connect. I connected suppose one resistor R. I connected one diode in such a way. In the problems you will ask to find the what now? AC output voltage. V0 is nothing but AC output voltage is required. How to find out the AC output voltage? But V0 is nothing but the voltage across this diode. But don't say V0 is nothing but the 0.7 SAR for silicon, 0.3 for the germanium. That is under DC analysis. This is under AC required. DC and AC are given means what way we can find the AC output voltage is more important. In that case, what now? At a time you cannot apply AC and DC to the diode. Initially, you must consider DC voltage source. If you consider DC voltage source, AC voltage source must be shorted. Voltage source AC means short. If it is a current source, it must be open circuited now. What I say, initially you must find current under DC analysis. Under DC analysis, I want to do this question at first. Under DC analysis, wherever the AC voltage source is given, you short I said now. I will connect only voltage V, DC only I will connect. There is a resistance R and there is a diode. Not given means it is a silicon, we can take it now. Practically we are using diode. Under DC analysis, voltage across diode is known, 0.7 voltage for silicon. Then you measure what current is passing through this side. That current is IDC. So IDC equal to how much I can say? V minus 0.7 divide by resistance R, you will get IDC directly. You will get IDC. Now AC analysis is more important now. Under AC analysis, what you have to do? Wherever DC source is given, that must be shorted. DC source is shorted. You must connect with AC source. V equal to Vm sin omega t. The resistor R you have to connect as it is. But under AC analysis, AC resistance of the diode is more important. AC resistance of the diode is given a name of dynamic resistance, RD only now. Under AC analysis, the resistance of the diode is called as a dynamic resistance only now. How we can find the dynamic resistance here? The dynamic resistance is calculated by eta into Vt by IDC they will apply by using this formula from the electronic devices and circuits. That formula is applied. But from this you can determine what is RD. But eta value is nothing but 1 for germanium, fixed value this one, and 2 for silicon you can use. 2 for silicon we can use now. Now we assumed it is nothing but the silicon. If it is a silicon means you can put the 2. Thermal equivalent of the voltage you will give 26 millivolts, otherwise 25 millivolts you will give. Whatever it is given you can put now. Vt value, thermal equivalent of the voltage 26 millivolts if not given. Sometimes they will give 25 millivolts. Yes, you can put now. You can determine the what now? You can determine what value? RD you can determine. Once you are getting the RD value, you think it's so. This voltage is nothing but the V0. We need to calculate AC output voltage. That V0 is nothing but voltage across this RD. AC output voltage, I can write directly. AC output voltage is calculated by according to voltage divider formula. V into this V, Vm sin omega t into RD by R plus RD. R plus RD they will apply. Then they will get the AC output voltage. The methodology is applied when you are connected a diode with AC and DC only. Now I want to give one gate question by using the what now? These two sources now. Yes, you know down the problem I will give. You can try this question. A problem is given like this. In the circuit shown, in the circuit shown in figure, if voltage drop, if voltage drop across each diode, each diode is 0.7 volts, is 0.7 voltage, and the thermal equivalent of the voltage, that is a Vt, 25 millivolts range it is given. If it is given 25 you must take 25 millivolts. Vi equal to input voltage is given Vp cos omega t where Vp is given 100 millivolts. 100 millivolts it is given. Is asking to find, what is asking to find? Question number 1. What is the value of IDC through diode? IDC through diode. It is given. This is the first question. What about the second question? Here given. What is the value of AC output voltage? AC output voltage. But I gave formulas for the both IDC, how to find the AC output voltage. The given network is here connected with one DC source. That voltage source 12.7 volts. 12.7 volts. 12.7 volts. Here connected with one AC source. That AC source is nothing but this VI. This VI is given. 9.9K resistor is connected here. 9.9K resistor. And 4 diodes are connected this side. 1, 2, 3, 4 diodes are connected like this. Such a way network is given. For one diode, I gave it dynamic resistance equal to eta into Vt by IDC. For 4 diodes, you multiply by 4. For each diode, I gave formula, multiply by 4. You will get the total resistance of these 4 diodes only. But IDC, I can get under DC analysis. Under DC analysis, wherever AC supply is given, AC voltage source is given, that must be shorted, you know. Anyhow, this is the V naught. AC output voltage V naught. Small v indicates AC output voltage. Small v suffix small o indicates AC output voltage. Yes, I will try. Under DC analysis, I wish to do initially under DC analysis. Under DC analysis, I can find. Under DC analysis, what I can do, wherever AC source is given, that must be shorted. Only DC source you must connect. And also resistance is a must. And 4 diodes are given. Those 4 diodes I will connect as T's, no doubt. The 4 diodes are connected here now. And the DC source is given here 12.7. 12.7 voltage it is given. The resistor here given is 9.9K. 9.9K. The drop across each diode is nothing but 0.7, no doubt. Not given means they were all made up of silicon. They were all made up of silicon only. Drop across each diode is 0.7 voltage. I wish to find what is IDC. This current I want. That I can get. How I can get that value? IDC I can get from this formula. IDC is nothing but current across 9.9K. According to Ohm's law, 12.7 minus 0.7 into 4 diodes. 4 into 0.7. Divide by total resistance 9.9K. 9.9K I can write. Yes, you can measure what is IDC. That IDC will be approximately 1 milliamperes it comes. You will get 1 milliampere of currents. That much current is possible. Yes, we are getting the what now? DC component of the current which is passing through the what now? This network. Now, under AC analysis, I want to measure AC output voltage. Under AC analysis, what I said, how I can do? I will do, please watch. Under AC analysis, I need to draw the diagram. But initially, eta value required, but the resistance of the what now? Diode is a must. Dynamic resistance is must for one diode. Finally, I will multiply by 4. Understand my point now. Eta into Vt by what? IDC, I give the formula. Eta is nothing but it is a silicon I have taken. Silicon means 2. Thermal equivalent of voltage, how much given in the problem? 25 millivoltage it is given. 25 millivolts. If it is given 25, you have to put 25. IDC is nothing but 1 milliampere. And finally, what are these? 25 into 2, 50. These two are cancelled. You will get in ohms only. This is for one diode. This is for one diode, dynamic resistance. 4 diodes we got now. 4 into 50, 200 ohms I can get now. I can redraw this diagram now. Under AC analysis, I can draw. There is a AC supply. This is a VI. Here connected with a resistor with a dynamic resistance. 4 diodes, equivalent resistance I have taken now. 4 into RD. RD is nothing but the 50. 4 into 50 is nothing but the 200 I can get now. 200 ohms I can get. This is V naught. The resistance here given is 9.9 K. 9.9 K is given here. I wish to find V naught. V naught is nothing but voltage across this 200 ohms. AC output voltage. Output voltage. This is given a symbol V naught. According to voltage divider formula, VI into what? 200 by 9.9 K plus 200 I can put now. That much value. We know what is VI. VI is given VP into what is VP? VP is nothing but 100 millivolts. 100 millivolts. 100 into 10 power minus 3 millivolts cos omega t. VP cos omega t is given divided by this value. 9.9 into 10 power 3 plus 200. But the V naught, this is a V naught only, sorry. It's a V naught. VI into, this is a V naught is nothing but VI is this much into what? 200 is there now. VI equal to VP cos omega t into 200 by this value. That's a V naught. And if you are using the calculator, approximately this value comes as, approximately its value is nothing but 2 cos omega t possible. 2 cos omega t is possible. Such a way, AC output voltage is calculated for what? AC and DC. And I wish to give one question in your hand. You please try yourself. I will not give any solution for this now. Just I will give one problem. You can try at home. One problem I will give. Same model question with AC and DC I want to give. Find AC output voltage for the network is given like this. There is a DC source of 15 volts here connected with AC supply, that is given 2 sin omega t millivolts, it is given. This is connected with 6K. Here one diode is connected. The diode is made up of germanium. And this side it is connected with 2 silicon diodes. One silicon, one germanium also we can put Y. One is a germanium we can put. In such a way I connected. I am asking to measure AC output voltage for this. V naught is required. You make an effort to get the solution of this question. This is the last problem for today's session. Thank you.